Hi, this is Mr. Merrill, and in this video we're going to talk about how to graph data in Logger Pro and to linearize that data to construct algebraic models that we can use in physics. So I have a sample experiment here. Let's just say that we have a bucket full of water and we can drill different size holes in the bottom of the bucket, and we can measure the area of those holes. And the area of those holes obviously is going to affect the time it takes for the water to drain out the bottom of that bucket. So for my independent variable I have area, for my dependent variable I have drainage time. So I want to take this data and enter it into Logger Pro so I can graph it and do all that nice stuff. So first of all, I want to make sure my labels on my columns here are the same as what I have on my sample data to the right. So I'm going to right click, go to column options, data set X, change this to whatever your independent variable is called. Like I said in this example, it's going to be area. Good short name or symbol for that would be A, and then the units are centimeters, and we can add a little squared by going to superscript 2. Right click on Y, changing this to drainage time, seconds, okay. So now you'd have to manually enter in however many data points you have, but I already have this copied, so I'm just going to paste it in. So you see, after you enter it in, it'll automatically graph that. Now there are some things that I don't like. For instance, we're only using about half the graph here. As you can see, our last data point was at an area of 4 centimeters squared, and then we have all this blank area. So sometimes it's goofy like that. We don't want to keep it like that. So I'm going to right click, go to graph options, and then instead of having this option where it says auto scale, I'm going to change it to manual. And instead of being 10, we're going to save some of that space by changing the last one to 4, because that's about where our last data point showed up. And I can also change it on the y-axis. Let's make this a nice number of 15. Okay, so there's a very simple way we can see the graph just based on our data in Logger Pro, instead of us having to manually draw those points out. But the problem with this is we can obviously see this relationship is not linear. And the problem with that is we don't know how to easily get a algebraic model when we have a graph shape like this. So I need to somehow develop a linear graph that takes in all of this data, and out of that linear graph then I can get an algebraic model. So say we have a hyperbola like this. It could be in any number of graph shapes, but if it's a hyperbola like this, our little cheat sheet tells us that to get a linear model, or to linearize this data, we need to graph y versus the inverse of x. So right now we're graphing x, but it's saying if instead on that horizontal axis you graph the inverse of x, or 1 divided by x, you will get a straight line. So it's saying instead of showing area down here, show 1 divided by the area. So first of all, we need to find out what 1 divided by the area is for each of these points. Now you can manually calculate it. So for instance, 1 divided by 0.5 is 2. 1 divided by 4 is 0.25. But suppose we don't want to do that manually for every point. We can have Logger Pro do that. So we want to go to data, new calculated column. We're going to call this new calculated column inverse area. Its short name is going to be 1 over A. And it's going to have units of 1 over centimeters squared. You could also say that it's to the negative 2, and some of you might prefer writing it like that. Okay, so now to have this manually take all those inverses for us, we're going to want to do 1 divided by, and then here we can just put the entire column of area. So then we can hit done. You can see our Logger Pro has automatically done that for all the data points. You know, depending on some of these other situations, you might have wanted Logger Pro to square the x coordinates or square the y coordinates. It's all just based on whatever original graph shape you have. So now I want to actually be able to see this graph. You can see right now it's still displaying the same exact graph it did before. To change that, I'm going to right click, go back to graph options, and here we can change what it shows on the x-axis. If you wanted to, you can also change what it shows on the y-axis by, say, clicking this. But we want to still show drainage time on the y-axis, but instead of area on the x-axis, we want to change it to inverse area. Go ahead and click done, and you'll see our graph has changed. It's now falling on a straight line, but because we're now dealing with new numbers, ranging from 0.25 to 2 instead of numbers from 0.5 to 4, our scaling is no longer really appropriate. So we're going to have to go back and change our scaling again, and we'll make this 2, and you can see our last data point nicely fits in, and we're using up the entirety of the graph. So why is this nice? Well, now we can have Logger Pro construct a best fit line. To do that, I'll hover over this option. You see where it says linear fit. Go ahead and click that. And Logger Pro is excellent in doing certain things. You see it automatically calculated the slope of this line. It says 6.892, and it even provides the units, seconds over centimeters to the -2. With a little bit of algebra, you can realize that's seconds times centimeters squared. It also provides an intercept. You can see this intercept is very, very, very small. This e is times 10, so we're talking about a number times 10 to the -11th. We can go ahead and assume that's 0, and that small difference is just unimportant to us. So this does not quite look like the algebraic models that I've shown you, but it's pretty easy to take what Logger Pro does and write an algebraic model. So I'll show you how to print this out in a second, but once you have it printed out, I want you to, right next to this box here, write what your algebraic model should be. So, to do that, what's on our y-axis, that's time. Our slope is 6.892. I talked about simplifying those units to seconds times centimeters squared. Now we have to think for a second of what's on our x-axis. It's inverse area, right? So on our x-axis, we have 1 over a. Right? If we think about this fitting the model of y equals mx plus b, our y-axis represents t, our slope is represented by this number that Logger Pro provided, our x-axis is representing the calculated column of inverse area. And then our b, as we discussed, this is such a small number that we really want to just assume that it's 0. And this is a complete algebraic model. I think the only tricky part is realizing that you want to write 1 over a here because that's what's being graphed on the x-axis and not just a. And you can see that the units work out too. Remember, what's the units of area? Centimeters squared, right? So the centimeters squared on the bottom here is going to cancel with the centimeters squared, and then you'd have seconds on this side with seconds on this side. So the last thing I'll show you how to do is to print this out. You can print directly off Logger Pro. You don't have to copy and paste into Word or anything like that. So you just go File, Print. This option here is probably grayed out if you haven't done it before. So go ahead and click on Print Footer, and you can enter in your name, and you can enter in whatever problem it is or whatever you want to call it. So let's just say this is problem 5, and there's my name, and you click OK. You can play with some options like having it print landscape. That's not really important. The default is fine with me. So go ahead and click OK. And like I said, you'll have this printed out along with your table, and I want to see both of those. And then you have to take the printout and manually write out an algebraic model that looks something like this. Okay, so hopefully you found that helpful. If you have any questions, just email me. Thanks.